In this series of videos, we're going to talk about the rest of section 11.6 of Stewart's book. That is, we'll cover two tests for whether a series converges or diverges, the ratio test and the root test. So let's start with the ratio test. Let's take this example of a series S, which is the sum from n equals 1 to infinity of n over 5 to the n. And we want to know whether S converges or diverges. And the main idea behind the ratio test is that we'll consider ratios of consecutive terms. That is, let's say that our series is a sum of terms an. The ratio test is called the ratio test because we're going to look at what happens when we divide an plus 1 by an. So let me be more precise. We're going to look at L, which is going to be the limit as n goes to infinity of an plus 1 over an, but not just the ratio of the terms, but we'll put in absolute values. So these are the ratios that we need to look at for the ratio test. So what happens in this example? Before I tell you exactly what the test says, let's look at this example. We have an plus 1 over an. This ratio with absolute values is the absolute value of n plus 1 over 5 to the n plus 1 over n over 5 to the n. Okay, so here, n plus 1, n, 5 to the n, 5 to the n plus 1, everything is positive. So the absolute values aren't doing anything. If we have a over b divided by c over d, we just flip the fraction in the denominator, and what we get is this ratio is n plus 1 divided by n times 5 to the n over 5 to the n plus 1. Why is this good? Because there's a huge amount of cancellation here. 5 to the n plus 1 is 5 to the n times 5. So this ratio is n plus 1 over n times 1 over 5. So what does that mean? So this L that we need to look at in the ratio test, the limit as n goes to infinity of this absolute value of the ratio of consecutive terms is the limit as n goes to infinity of n plus 1 over n times 1 over 5. We know that n plus 1 over n is going to 1. 1 over 5 is 1 over 5. So this limit of the ratio of consecutive terms is 1 over 5. Well, what does that mean? What does that tell us about whether S converges or diverges? The ratio test says if L falls into 3 different categories, we can say different things. So if L is less than 1, S converges. It says even more than that. It says that, in fact, S is absolutely convergent. That S will still converge if we put absolute values in around an. Why does that make sense? Well, we're not just looking at the ratio of consecutive terms, but the ratio of the absolute value of the ratio of consecutive terms. So it makes sense that this convergence test would tell you something about what happens when you replace an with absolute value of an. Okay, so that's what happens if L is less than 1. If L is bigger than 1, then S diverges. Right, so not only does S diverge, but S plus, when you put in the absolute values, also diverges. So what's the one thing that we've left out here? Well, if L is less than 1, if L is greater than 1, what does the ratio test tell you if L is equal to 1? The ratio test tells you nothing. So the test is inconclusive. Maybe S converges, maybe S diverges, but the main thing is you have to try another test. So what about this example? In this example, L is 1/5, which is less than 1. So S converges by the ratio test. So S converges here. In fact, the ratio test says S converges absolutely, but putting absolute values in around AN doesn't change anything because these ANs are already positive. So what do you have to do to apply the ratio test? The big thing is algebraic, is you have to find a nice way to represent AN plus 1 over AN. What do I mean nice? I mean, you do whatever cancellation you need to do so that you can take the limit of this ratio and see whether it goes to something bigger than 1, less than 1, or equal to 1. So in the next video, we're just going to do a few examples where we apply the ratio test to see whether or not a series converges.